Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples.
Good morning, and welcome back to Stories from Space. I'm your host, Matt Williams, and with me in the booth today is famed author, physicist, NASA technologist, and a member of the International Academy of Astronautics, and fellow of the British Interplanetary Society. I give you Les Johnson. Les, welcome aboard.
Oh, glad to be here.
So, the subject of today, of which you are perhaps the most qualified individual to speak to, is interstellar travel. Is this something humanity can look forward to? Is it currently something that is still a dream, possibly generations away or centuries, and other related questions? So my first question for you, though, is could you tell us a little bit about your journey? How you got from, say, inspiration and an interest in space to becoming a NASA technologist and a famed author who writes about this quite considerably.
Well, I don't know about the famed part of it, but I'll take the author part. And I have to give a disclaimer that although I work for NASA, I write books on my own time, and any opinion I give here is just my own, not my employer. Although there are times when I wish they were my employers. The journey for me, I'm pretty typical for a lot of NASA employees in terms of interest in space. I watched Neil Armstrong walk on the moon when I was 7 years old. My parents woke me up late at night. I think it was 11 o'clock Eastern time. I was probably wearing footy pajamas, watched a little grainy black and white picture of that. My sister hooked me on Star Trek, the original series, watching the reruns with her late on Friday nights down in our basement. And I was always kind of a nerdy kid anyway. I was doing a lot of reading, very good at science and math. And so I decided I wanted to work for NASA. And that pretty much has been my single-minded determination since I was about 12 years old. So I went to undergraduate school, got a BA in physics, got a good, well-rounded liberal arts degree, which is what I think has helped me dramatically in my work as well as my writing. Then I went on to Vanderbilt and studied physics, got my master's degree. Went to work for a company here in Huntsville doing defense stuff because the first job I applied for at NASA I didn't get. And I applied again and I started working for the agency back in 1990, working on different advanced propulsion, but not really with interstellar in mind. Until around the year 2000, so 22 years ago, it just seems like yesterday, there was a study going to be conducted at NASA's Jet Propulsion Laboratory on a successor mission to Voyager called Interstellar Probe. And the goal was to send a robotic probe out of the solar system traveling 3 times faster than Voyager, not to reach another star, but to eventually get to about 500 to 1,000 astronomical units before the people who launched it died. To be blunt, that was kind of one of their requirements. They wanted to see their data after they launched it. So I got involved in that study and realized that there are a lot of technologies that had not been developed for space propulsion once you leave the Earth and once you get out into space, in space propulsion, which is a very different problem than just getting out of the gravity well. And I got involved in looking at a lot of these and realized that some of them could eventually lead not only to meeting the needs of that interstellar probe mission, but from a physics point of view, could conceivably be scaled up to allow us to take a reasonable trip to another star in the future, even though we have no clue how to engineer those systems right now. So that's what got me engaged. And I started working on solar sails, nuclear propulsion, ion propulsion, and eventually settled primarily working on something called light sails, solar and laser sails. But that's what got my interest professionally in interstellar. But it was way cool for me because I've also been a lifelong science fiction reader. So as I got involved looking at laser sails and solar sails, I was thinking back to some of the great science fiction stories I read as a kid and as a young adult. And here I was trying to help make them real, which couldn't be any cooler for somebody than that, to me anyway. So that's kind of my story.
Yeah, in fact, I'm hearing a lot of parallels, and it sounds like your work preceded these projects by quite a bit. But I'm hearing some parallels to Project Dragonfly and Breakthrough Starshot, and of course the work of Harold Sonny White, and Cuvier Drive. Is it well, now for starters, did you and NASA Eagle works there? Did your work ever coincide with what Sonny White was doing?
Sonny White came along a little bit later, but yeah, he and I have crossed paths many times through our NASA connections. We were both doing some NASA work not related to Interstellar together. And then since we realized we had a common love and passion, we've been in communication since then. Sonny and his organization has been a sponsor of the Interstellar Research Group Symposia in the past. And so he and I speak often. I've been a reviewer for some of his grants that he's issued. I had the benefit of being mentored by the great Dr. Robert Forward. You mentioned Project Dragonfly and such. He came up with a lot of those ideas for interstellar travel, and I got to know Bob before he passed way too early, over 20 years ago. So yeah, and the Breakthrough Starshot folks, I am kind of an informal on and off again consultant for them on light sails, and have been to several of their meetings. So that's an exciting activity where they are actually working toward launching a robotic interstellar probe in the near term, which would be awesome. But they have a lot of technology challenges to overcome to get there.
Absolutely, yeah. So yeah, in this report here on the interstellar probe is it fair to say light sail technology was considered the best bet for powering this probe?
Well, in the original studies, it was one of the leading candidates. That and nuclear fission electric propulsion. We have solar electric propulsion craft, but when you get far from the sun, of course, you don't have the sun to power it, so you have to bring along a power source. So the early studies said that we really ought to be investing in nuclear reactors for spacecraft, solar and laser sails, and all that. Now the mission concept for Interstellar Probe has evolved over the last 20-some years. There's a new incarnation of the mission, same goals, essentially, but they're no longer going to depend on advanced propulsion. I think they got tired of waiting on it to be matured. And so they have looked at how you might do the mission using chemical rockets with close solar passes, kind of a gravity assist at the sun. And it turns out you can get a pretty rapid escape from the solar system doing the brute force approach with rockets, but it'll pretty much be a dead end. That approach won't be a stepping stone to Alpha Centauri. It'll do the interstellar probe, but it won't really help us get going any faster than that. So it's a great mission from a science point of view, probably implementable in the near to medium term. I absolutely support doing it, but it's not really going to be the stepping stone to the stars that I had hoped it would be.
I see. So looking at, just based on what you're saying here, looking at light sails and advanced propulsion there over time, I do feel like there's been sort of an evolution there, and correct me if I'm wrong, but it started sort of with nuclear pulse propulsion, then evolved to nuclear rockets, fusion rockets, light sails. I would imagine there's been some overlap there too, and maybe even a few callbacks. Like, yeah, we haven't investigated this in a little while. Let's consider that again. But was nuclear pulse propulsion, for example, was that the first interstellar concept?
I don't think it started as an interstellar concept. It started as a response to the Cold War and the potential militarization of space. The whole pulse approach, of course, the great Freeman Dyson was instrumental in that, in developing the ideas behind Project Orion. And for the listeners who may not be familiar with that, it is I'd say a brutishly elegant propulsion system that we'll never build. Imagine, building a big steel ablative plate the size of the first floor of a skyscraper, and the rest of the skyscraper's made, hermetically sealed for space, and you put people and supplies in there, and then under that big steel plate you start exploding hydrogen bombs once every 3 seconds to get it off the ground and get it into space. And you keep doing that after you're in space to accelerate up to, 5-10% the speed of light. Physically, it should be possible. And there are actually some non-nuclear explosive tests done that you can see really cool videos of on the internet. But this was all developed. The idea was initially developed, it's my understanding, as a way to fight the Cold War if it got hot in space. that we would launch a whole bunch of these from the ground to go fight the Soviet Union in orbit, right? And it was after they had done the analysis of how well this performed that they realized, hey, wait a minute, we might be able to use this to send the probe to another star. Of course, it would be a Hail Mary last-ditch effort, because if you did that, you would, of course, contaminate the biosphere pretty significantly. Yeah. So I don't think we're going to be doing that anytime soon. And then that also led then to the ideas of, well, can we mimic, the power source of the sun with nuclear fusion, which physicists have been trying to do for power for decades. And physics says, yeah, you can do this. It's just the engineering hadn't caught up with it. And once we have fusion power, then the next step would be miniaturizing the system so you can put it on a spacecraft and use it in space. So it's one of those things that from a feasibility point of view, yeah, we ought to be able to do it. But engineering hasn't caught up with that possibility yet, with nuclear anyway.
Yeah. And I do very much like that description. I said something very similar once, that NPP was brutalistic, but undeniably it would be effective, right?
It would be effective. I was on I guess it was a Discovery Channel show about evacuating Earth that was going to postulate that the whole world was going to be destroyed. How would you save humanity? And the idea, that was the one I settled on as the most near-term way to send some kind of space ark out. And if the planet were going to be destroyed anyway, what the heck?
Yeah.
So, but only under those circumstances.
Yeah. And I mean, it was an elegant idea in its own way when it evolved into, we could use this for interstellar travel, right? It was kind of like swords into plowshares. We've got no shortage of nukes, so stick them in a ship, use them as propulsion. There's that. That's my understanding anyway, that sort of evolved that way.
Yeah, that's my understanding also. And I had the opportunity to discuss this with Dr. Dyson at a workshop a few years ago. And I was, quite a fanboy. I got a picture with him, of course, but I didn't have a copy of any of his papers to get signed. I wish I had. But he described some of their antics and how they tested that. And that was a different era. They actually did some unofficial testing with requisitioned explosives that they didn't actually requisition during the night, because they couldn't get approval to do official tests, and eventually they got approval to do it. But today that would land people in prison, right? But I guess the 50s were a different era. It was a lot of fun talking to him about that.
Oh, I imagine. Now, in terms of fusion rockets, I wanted to mention, since you mentioned some specifics there, Project Orion, Project Daedalus, and since then Project Icarus. These are feasibility studies to try and realize a fusion rocket. Now, in that case, what exactly is the power source? How does that work there? You mentioned miniaturizing the sun, but can you explain to the listeners using words like deuterium pellets?
Well, the way I'm going to go even simpler than that, because I don't know how they're actually going to get it to work in miniature, right? There are lots of different ways to do a fusion reaction. Of course, the sun does it brute force. I mean, it's the mass of all that hydrogen being squeezed together until finally the helium gets squeezed together enough, and the hydrogen gets squeezed together enough, and it becomes helium, releases energy. And that's the outward pressure that keeps the sun from collapsing on itself and causes it to shine. All that energy is released. Then there are ways to do fusion where you have the heavy hydrogen, the deuterium reaction. There are ways that use helium-3, which is one of the reasons that people want to mine the moon to get the helium-3 that's been deposited there from the solar wind to help catalyze the fusion reaction. One of the most elegant solutions I saw for miniaturizing it, but it has problems in and of itself, is that you get a fusion fuel, but you catalyze the reaction by injecting antimatter into it. And you get the fusion reaction going by squirting in a little bit of antimatter here and there. And that looked really, really promising, again, from a fundamental physics point of view. But then you have the problems of, well, how do you create, capture, and safely store enough antimatter? So, a thimble full of antimatter would blow up a medium-sized city. So you have to be really careful with that stuff. But at the basic level, that ought to work.
Yeah. And so in terms of nuclear rockets, so nuclear, thermal, nuclear, electric, right? That is That is something we could see very soon, if I'm
Oh
not
yeah.
mistaken. Aside from the obvious aspect of it's going to cost a lot to build these, they are, fully realizable using technology we understand.
That's right. We build solar electric propulsion today. We could build with existing technology or very short development cycle technology, nuclear electric or nuclear thermal rockets. And as much as I like those for exploring the solar system and perhaps for this interstellar probe mission, they're technological dead ends to go to the stars. I mean, right now, technically speaking, Voyager is an interstellar mission because in about 70,000 years, if it were pointed toward the nearest star, it would reach the nearest star. So technically, we could launch a mission to another star system today, but I don't think it's very practical to send a dead spacecraft on a 70,000 year voyage, right? And so nuclear electric and nuclear thermal rockets might get that trip time down to 55,000 years. Okay, well, that's an improvement, but it's still not where we need to be. So I put those in the category like I do chemical rockets of things we need, but they're really technological dead ends. Even at 100% efficiency from a physics point of view, they just don't contain the energy density you need to get to the stars in 1,000 years, let alone hundreds of years or a decade.
And yeah, in fact, Dr. White had said something similar there. In fact, their approach over at Limitless Space, which he joined, was that yes, nuclear thermal or fusion thermal, those concepts are going to be good for interplanetary, but by the time we get to interstellar, which is sort of like step 3, yeah, we're going to need to be looking at truly exotic means of space travel, but there's time for that. So would it be fair to say that light sails, they're considered the solution for interstellar travel because everything we've got that can be realized now is too slow. Everything that would be fast enough is still too exotic, too speculative, and like an uncrewed probe that it's got a small spacecraft, a wafer craft, and a big light sail. That this is what we can do right now?
No.
No.
I wish it were. I think it's something we might be able to do sooner than the other approaches.
Okay.
But it's not something we can do right now. The breakthrough Starshot people have, and Dr. Philip Lubin, who came up with the approach of the Starshot wafer with light sails, it's a really great idea. Basically, you build a small sail. Doesn't have to be as big as some that I've envisioned, which are square kilometers in size. Maybe this one's only a few square meters. But you hit it with a really powerful, like gigawatt laser to accelerate it out of the solar system rapidly, carrying a spacecraft that just weighs a few grams. Now, that all sounds great until you start thinking about, do we have any materials that can survive gigawatts per square meter of energy deposition without becoming, vaporized in the process? And the answer is maybe, maybe not. And the testing and the data and the verdict is still out on that. Then there's the question of, well, how do you power and build such a big laser and keep it collimated, focused, and coherent to accelerate the spacecraft? And again, there are people who have ideas how to do that and are testing some scaling up, but we got to scale up to have lasers where you have your own dedicated nuclear reactor to power them in order to send these probes off. So when you say we could build them, I think, compared to these other things like miniaturizing a fusion reactor to put on a spacecraft or trapping antimatter and putting it on a spacecraft, I think the light sail or the laser sail approach is probably less expensive and nearer term, but under no stretch of the imagination would I put it in the category of we could just go build it now. I don't think that's possible.
Right. So not fair to say right now, more like sooner other than later.
Yes.
Yeah. Okay.
And please don't take any of these comments as being negative. I'm encouraged.
Oh, yeah.
I'm absolutely encouraged. We need to take these first steps. We need to be making this fundamental research because I think going to visit and send probes to these extrasolar planets we're discovering, that was the whole motivation for a lot of my career and for me writing my book, A Traveler's Guide to the Stars. I mean, that's what inspired me, and that's what I'm hoping to get that next generation of researchers that I can pass the torch to. I really want to get them some resources and inspiration. So yeah, absolutely, we need to be working on it.
Yeah, well, also, yeah, I would very much like to talk to you about the books you have written and co-authored and edited. In particular, a previous volume of yours, which was an anthology of science fiction and scientific essays going interstellar. What kind of propulsion concepts did you explore in that book?
Well, that book was a lot of fun to put together because it's an anthology of original stories by different authors, as well as some nonfiction essays, which are kind of the science behind the fiction. I would call that a precursor book to a traveler's guide. And the different authors who contributed, just like Matt, like you've contributed to the anthology, the Ross 248 project, which will be coming out from Bain in the spring. You wrote a nice piece on terraforming for that. And we had people write, like Dr. Greg Matloff, who's been one of the inspirations for me and kind of a mentor for me in light sails. He wrote a chapter on beamed energy propulsion and light sails for interstellar travel. And then we have short stories by great writers like the late Ben Bova, Jackie McDevitt, Mike Resnick. Some tremendous science fiction writers wrote original stories based on realistic, plausible scenarios. No warp drives, with no offense to Sonny. Physics we know and understand, things that we might be able to engineer in the future, realistic scenarios. And the purpose of that collection was to entertain and educate. And I was thrilled that my publisher, Bain Books, created a free teacher's guide that they make available in PDF format from their website, so that high school teachers could download this, and it could be part of the curriculum for physics students to be exposed to literature, and for the lit students to learn a little bit of science. So that whole thing ended up being an entertaining, educational, and in some schools, it's my understanding, it's actually been used in some high school classes. So I feel real good about that anthology. It was quite a success and a lot of fun to put together.
Yeah, well, thank you for bringing up the Ross 248 project. We'll definitely get into that in a second there, because I have a lot of questions relating to that one. I think the listeners would be interested to hear the details about that, because fascinating subject. But my next question, speaking of realizable things, concepts that we can do using known technology, the idea of sending humans to other star systems. Right, if we're talking about uncrewed probes, light sails are a good idea that we could realize in the near future. But in the meantime, are things like generation ships or cryo ships, are those what we're kind of stuck with if we're being realistic and we are thinking of sending human beings to other stars?
Well, I guess I have to once again put things in perspective. If you want to accelerate a pineapple to like 10% the speed of light, with 100% efficiency, the kinetic energy of its motion, just from traveling that fast with that weight, it's about a kilogram, would have the equivalent of 7 Hiroshima atomic bombs worth of energy. And to accelerate just something the size of a pineapple to 10% the speed of light, which would give you a 40 or 50-year trip time to the nearest star, is an enormous challenge. If we then scale that up to sending, say, a battleship or an aircraft carrier, which is probably the closest example of a closed ecosystem of people that you would have to an interstellar ship, I think the challenges of doing that are just beyond anything that I can imagine right now. And so most of my work has been focused on the robotic probe with an eye toward enabling the human approach. But once you start sending these generation ships, I don't know if putting people to sleep is possible. It's science fiction. There are people working in torpor research, hibernating. There've been people who've survived being under the ice because they got cold, right? But as far as I know, you still age. You don't, you don't get in your, cryo bed looking like Viral Vic and wake up 50 years later and you've aged a day. You'd wake up 50 years later and you're near retirement age.
Oh my.
So unless we find a way to turn off aging, I don't think the whole cryo or sleep approach will work, which means we're going to have generation ships. And that's fine, except now you got to keep people alive on this ship for hundreds of years and have their descendants grow into taking over crew of the ship, and you get into all kinds of ethical issues there. So that's where the ethicists need to come in. And we really need breakthroughs in biotechnology. So I'm going to place the burden, not just on the physicists and the engineers, but on the biologists out there to come up with some solutions to the problems that world ships pose.
Well, take that, cryogenics. Yeah. But there's a reason. There's a reason that was a fad well over 20 years ago, right? And not so much today. Yeah, I think today the fad is telomere lengthening, but yeah, that's got a long way to go. All that research, yeah. So in terms of what I would really wanted to get you on here to explain to me, I mean, I'm relatively familiar with the antimatter propulsion concept, right? You're slamming hydrogen atoms and anti-hydrogen atoms together to create a big kaboom, and you channel that through a nozzle there that generates propulsion. It would take a really, really large amount of that, though, to actually accelerate a ship. And yes, and Dr. White, he explained the Alcubierre metric to myself and the viewers like we were 10 years old. But what about the black hole drive? I've been hearing about this, and the basic concept, I guess I'm familiar with, but do you have any information on that, on how that would work?
Well, I'm not sure I know specifically which black hole drive you're talking about. I mean, I've heard the notion that black holes are connected to white holes by a wormhole, and you can short circuit yourself across the universe. I think there have been some theoretical physicists who said these things might exist, and that's wonderful. But there are no black holes close, which is a good thing. So you'd still have to develop the kind of interstellar drives I'm talking about, or Sonny's talking about, to get there, to take advantage of that black hole. So you'd still have to have some kind of more conventional interstellar drive just to get to where you want to take your shortcut across the universe. And then I've also read speculative fiction about where you might generate a black hole ahead of your ship and keep it there somehow, and your ship then gets attracted and accelerated forward. And if the black hole is always some fixed distance from the front of your ship moving with you as you're accelerating, then you're constantly falling into it and accelerating faster and faster. I think that violates conservation of momentum somewhere. So I'm really dubious about whether that'll work or not. But I don't know if those are the ones you're talking about.
Well, the first one, yeah, that is one that I've heard. There's also a variation, what's called the halo drive, where if you allow your ship to fall into orbit around a black hole, and it accelerates you, and if you then break off at the right time, you're then sort of you're catapulted to where you're going. But you better have a very good pilot or system there to do that, right? There was one other, though, that said if you could generate a tiny black hole in a small chamber with lasers just firing on one little spot in the middle there, and create a infinite mass density, then you'd have a miniature black hole that you could draw energy from. That's the best of my recollection. That is the black hole drive that I'm thinking of.
Well, I'm going to put that firmly into the I'm extremely skeptical category.
Yep.
Not only of the physics, but of how you would ever realize it. With things like antimatter, we don't know how to build the things that create antimatter to scale, but we know how antimatter is created. We know that you can store it if you have a perfect vacuum and strong electromagnetic fields. We just don't know how to make a strong electromagnetic field to contain antimatter and have a perfect vacuum at the same time, let alone generate enough antimatter to put in it. But we know generally how you'd start. But I have no idea how you'd start to do that. That eludes me. So I guess I'll have to defer to other people who know more about that one than I do.
Well, yeah, like I said, it's definitely in the speculative column, and I do believe it's. I only read about it in the context of science fiction, but the guy who wrote it was Charles Strauss, and I believe he has some training in that.
He
domain.
does.
So,
I've read about him, but I have not read about that particular activity.
So to circle back to what you mentioned earlier about the Ross 248 project, I definitely am very, very happy to be working on this with you and Ken Roy and the other authors, especially because it concerns the whole idea of red dwarf habitability. And that's been a major issue in recent years, hasn't it?
Well, it's been in the news a lot. I've seen, I'm not an exoplanet specialist, but I do keep up with what's going on in that field. And since there are so many red dwarfs out there, people have been looking at, well, what is the habitability zone? Are these stars flare stars? Could there be planets with life around these stars? And if so, they're going to be really close in. Just lots of interesting stuff to keep up with.
Mm-hmm. And that's especially significant, right, for a bunch of reasons. In case for my viewers who may not be aware, the recent exoplanet discoveries there, the recent spate of them, some of them have been very near to home and have involved red dwarf stars, have they not?
That's my understanding. Yeah, I've been, like I say, I keep up with it. I check the exoplanet database, I won't say every day, but probably at least once a month to find out if there's things that I haven't had come up in my, Google customized news feed.
Yes.
And I check sites like Universe Today, Space.com, and those to look for these kind of articles because it's part of what motivates me. I like to find out what's out there.
Mm-hmm. And in fact, got a funny story or two about Universe Today. In 2016, when the European Southern Observatory, they announced that right next door there is a potentially habitable planet orbiting Proxima Centauri. And not long thereafter there, I think it was, 2017, they announced the TRAPPIST-1 system, 7 rocky planets around one star, and 3 of them are sort of in the habitable zone. So it's discoveries like these that really brought the question, are red dwarfs habitable, into focus.
It is. And the Ross 248 anthology that to which you refer, that's coming out from Bain, we picked Ross 248 because no one's discovered planets around it yet. And we didn't want to pick TRAPPIST because just as soon as we pick something that someone's already found, they're going to find reasons that it won't be what we think it is, right? With all the planetary systems. I've written science fiction stories in the past that, 8 years after they're written, they're overcome by events and are stale because the science has changed or surpassed what was written about. So we picked a red dwarf system that we don't really know if there are planets around it yet, and we're probably not likely to find out anytime soon. And that gave it a pretty rich realm for science fiction, to figure out what these hypothetical planets might be like. So I think people should think of it as taking the TRAPPIST planets and putting them around a different star so that we have a fictional setting. And it'd be really nice to find out, some statistics. And I think we're getting those statistics about the planetary systems that are around red dwarf stars. So you could do a better estimate, given that we know there are a lot of red dwarfs out there. How many of them have planetary systems and of what type. But to do that, you have to get, lots of confirmed exoplanets around red dwarfs to get, numbers up so you can have some meaningful statistics. I think it'll be interesting to follow.
Yes. So, and another aspect of red dwarfs that make them really important to astronomers and figuring out questions related to their habitability is the fact that they're just so common, right? 75 to 80% of stars in any given galaxy are red dwarf suns. And from what exoplanet studies have shown us, they seem to be very, very good at creating rocky planets around them. Now, the question of habitability of red dwarf suns, though, what challenges have we seen to that? Like, what is standing in the way of us just going to the nearest red dwarf sun and setting up shop on one of its habitable zone planets?
Well, again, I think it's the same thing that is basically stopping us from going to any other nearby star, right? I mean, the technological challenges of getting there. But we're also handicapped. Even if we were to suddenly have a space drive that could get us to Proxima Centauri B, right, say in 100 years or less, and we suddenly had this breakthrough and we decided, all right, let's go. You would have to send robots first, because at this distance, we still would not, most likely would not be able to know, are any of these planets, do they have atmospheres? And if they do, what are those atmospheres like? What is the planetary surface like? You don't want to commit to sending, people until you get that kind of data. And we're so far away, and those star systems are so dim, it's going to take next generation after the next generation telescopes probably to get the kind of spectroscopic observation of the atmospheres of some of these small planets, let alone get imaging. And those are the kinds of things I think we need to know before we commit to sending people. That's why I think we'll ultimately send robots first to do scout missions. There is one pretty exciting mission out there, though. It's called the Solar Gravity Lens mission. That's kind of spearheaded by JPL's Dr. Slava Trudishev. And that's the notion of basically putting a big telescope out at the Earth's solar gravity lens focus, where the gravitational bending of space-time by our sun basically forms a focus like a magnifying glass focus, not really, but similar, and allows you to magnify. And if you put a telescope there at the right place and the right time, you might be able to image and get really good data about one of these exoplanets. But that's a big mission to undertake. You have to go 550 AU, which is much farther than Voyager's traveled yet, and it's been flying for over 40 years. So we're still a ways from even that. But I think we're looking at it. People are taking those first steps. And those are the steps we have to take, I think, before we'll ever, even if we had the technology to go now, before we'd send people, we'd have to do those kinds of reconnaissance.
Mm-hmm. And this actually, this ties in nicely with the whole issue of exoplanet studies, right? To date, our methods are largely indirect. We're looking forward to the day when direct imaging is going to be possible. But with red dwarf suns, that is particularly hard because, yeah, they're really quite dim. There are expectations that James Webb will be able to help out in this regard with its advanced infrared optics, but yeah, it's going to be a ways. So we're kind of stuck with theoretical approaches to the whole habitability question right now, huh?
I think we are, and I think we'll be handicapped with that regard for a while. However, you have to remember this field of study didn't really begin until the 1990s. I mean, it's a relatively new field. That's when the first confirmed exoplanets were discovered. And, some of your listeners are like me. They remember the 1990s, and it doesn't seem that far ago, right? So I think who knows what's going to happen with James Webb and some of these successor instruments and telescopes over the next 25 years. If we come as far as we've come since the 90s in the next 25, 30 years, then, we may start getting some of that data. I don't want to underestimate the pace of technological change. I'm still optimistic.
Yeah, it does seem to come down to we're just going to have to wait on future developments some more and future discoveries.
Well, you got to be careful, though, because, your listener base is pretty broad, right? And you don't want to have too many people wait or nobody's doing. So what you want to do is you want to have the people who have the skills who are listening to the show or students who are in college, graduate school, high school to say, let's not wait. I'd like to help make that happen. And that might shape their career and actually contribute to getting the data we need. So let's be careful when we say let's wait. I don't believe in waiting. I think we need to get people moving so that it comes sooner than later. But again, that's my personality. I'm one of these let's just do it people.
Yeah. Well, no, yeah, and I like that. I like that attitude. Because there is a degree of cynicism, isn't there, when it comes to just the big missions, the big questions, the big tasks. They say, oh, that's not going to happen anytime soon. Why are we talking about it? And that's a good point. It's like we're talking about it because we need to get rolling on this, right? If we're not already
absolutely. You're right. I mean, the Apollo program was not born because the German rocket scientists and the science and politicians in the United States said, well, let's just wait and see what happens. It took a president to make a commitment that said, okay, no, we're just going to do this thing. And you have to have that. And behind that statement by the president were people who knew how to do it, or at least a path to take to doing it. I was fortunate in my early career to get to talk to some of the German rocket scientists before they passed, the ones who actually built the first rockets, the V2s back in World War II. And before the war, they were wanting to do this for scientific reasons. And of course, being, good Germans, they were drafted into their army to do it for military reasons. But, they were not going to wait. They said, we can do this. Let's just do it. And they did.
Did that include Werner von Braun?
I did not meet von Braun. He passed away before I moved down here and started working in Huntsville. But I met George von Tiesenhausen, Konrad Dannenberg. I had Konrad in our home talking to us about his experiences at Peenemünde, building the V2s that, of course, were raining death and destruction on England, and then how that all transitioned into the development of our first generation ICBMs and the Redstone rocket here that eventually took Alan Shepard to space. So it was really insightful talking to someone who basically made the history that so many of us have just read about.
Well, yeah, now getting back to that is a very, very rich field, and I wish we had more time, but I suppose we can say that for another episode. But getting back to the Ross 248 project, so in terms of what this book explores, like going interstellar, there we have science fiction stories and scientific essays. Now, a key part of this is terraforming, right? Like, if in fact the planets that are orbiting red dwarf stars, if there are questions of if they're not quite up to our habitability standards, there are ways in which we could engineer them to get them to that point. And for me, of course, that was a real source of fun to participate in this because frankly, I love to talk about terraforming.
Well, we asked you to write that essay because I'd read many of your online essays about terraforming, and it sure seemed like you had a good understanding of the broad spectrum of what people are talking about doing. So no, that was a fantastic contribution. No, the Ross 248 project is really the third in a series of anthologies. They're all standalone and independent, of course. It began with Going Interstellar, about how to get there and the technologies of going, and the stories, adventure stories of basically the people that go. And then it picked up with the Stellaris, People of the Stars anthology that I co-edited with Dr. Rob Hampson. And it was really about the human element and what will become of the people. Will we genetically engineer ourselves? What's the state of the art in some of the technologies for human augmentation, for cryosleep, those kinds of things. And then we had stories pertaining to that in the anthology. And now the Ross 248 project, which is, after you get there, primarily, what do you do? And it's not, the stories don't all take place at the same time, because when you undertake terraforming, you again have to have that long view. You're not going to arrive and 6 months later turn Venus into Earth. It might take centuries, right? So you've got to have that long view. What are you going to do in the interim, and how do the people and the generations of people that go going to deal with those challenges? That's where the human element comes in. I mean, we're still going to be people. So there's going to be deceitful people, there are going to be good people, dedicated people, slackers, and how do we deal with the unknowns that nature throws at us? So those are the makings of good stories, right? And that's why I think that the stories that are in there, people are going to be learning something, but they're also going to just be on the edge of their seat, entertained. If by my read of the contributor stories, at least I was, as I was editing, it was a great experience.
And yes, I mean, I'm glad you mentioned Venus and Mars. Yeah, terraforming has been something that we've been speculating about quite considerably since the early space age. In fact, I recently did an episode on terraforming for this show, in which I discussed how theoretical proposals going back to the early space age, especially from individuals like Carl Sagan, they looked at how we could terraform Venus and Mars, which are sort of at the opposite ends of the habitability spectrum, if you will, and how we've been attempting to apply that to exoplanets in the near future. So what we find out there will be very, very interesting and challenging, and depending upon the environments we find out there, we'll be applying this theory and the lessons that we accrue over time to those. And yeah, that does bring us back to interstellar travel, though, correct? It's that we need to have a much better sense of what we're dealing with out there before we actually seriously contemplate how we're going to settle out there.
Oh, yeah. I mean, I would imagine, and of course, things may change when we actually reach the point of doing this. I would imagine that the reconnaissance I spoke of, where you would want to get some data about the planets you're going to before you go with people, you would have to outfit the people and the voyagers with the tools they need to terraform the types of planets that they're going to encounter. And that's why I would think you would want to have a lot of scientific data about each candidate planet, so you could adequately assess, okay, for instance, in the anthology, there's a water world called Poseidon. If you have a almost completely covered world with water, and some kind of an atmosphere that's not necessarily immediately breathable, how do you modify that world versus one that might be more like Mars, right? Where it might have water, ice, frozen underground, or maybe every now and then flowing on the surface, but otherwise it's primarily a dry desert-like landscape. And so I would think, before you set out on your trip, you'd want to know, what are we going to?
Yes.
So that we can take the right stuff and the right expertise and the right materials to undertake this challenge. And then my co-editor, Ken Roy, he really believes that we might not do any of that in the near term. We might just go find a small moon or asteroid and build what he calls a shell world, which is basically you put a roof over the whole asteroid and create your own atmosphere in there, and then get the surface to be what you need. So you create basically your own encased mini world that you have more control over while you're there. It's still a big undertaking, but it might not be as difficult to do as like terraforming Venus, for instance. So anyway, it's all intellectually interesting, but when you start getting to the details, even the people who've thought about this a lot, they don't have a real plan, at least that I've seen, that would cover everything you have to do in these worlds to make a biosphere to accommodate Earth life. I think nature will throw a lot of surprises at us as we try to do that.
Oh, absolutely. I mean, any plans that we have no plans right now. Any proposals, I should say, that we have right now are still very highly theoretical. Yeah. There's no telling what kind of feedbacks will develop as we start doing all this ecological engineering. But yeah, a question I want to ask you is, do you imagine there will be a point in humanity's future where we actually do get a chance to terraform Mars or Venus? And, would that be a worthy endeavor?
Well, the answer to the first part of your question is I sincerely hope so. I think we have to worry about the great filter, right? We're gonna filter ourselves out of existence or out of an industrial technological society before we have a chance to do that. And that is a risk, and it's really become a real risk only in the last 100 years with the invention of nuclear weapons and now the biotech revolution. Not to mention climate change, right? So we have our challenges to get through, but assuming we get through those, yes, we should. And in fact, I think one of the ways to survive the great filter is as soon as we have the capability to start modifying one of these worlds to be another home for humanity, we ought to start doing that. But I've got to be careful. I'm not one who believes we ought to escape this beautiful planet, which is, tailor-made for us or us for it, because I don't think we'll ever find anything as beautiful and worth preserving as the Earth. And so I think before we start talking about terraforming Mars and Venus, we need to talk about reverse terraforming Earth, because we are, with the carbon emissions and a lot of the pollution, we need to find ways to undo that and make Earth more of the garden that we live in than we are doing right now. So I want to be a good steward here too, and I think everybody should realize that. I'm not an escapist. I don't want to run away from our problems. We need to tackle them here at the same time we're doing these other things.
Yeah, that is the challenge there. It's this idea of going interplanetary to save humanity. That certainly sounds like a very good goal, but it does sound like for some this is an escapist plan. It's our parachute. We're basically writing Earth off and so forth. Yeah, the best argument I ever heard for settling on other planets and even ecologically engineering them was this will foster all kinds of technology and innovation that will help us here at home. And who knows, Mars and Venus could even be test beds for things that we will need to do here in order to basically repair all the damage we've done.
It could be.
Yes.
Absolutely. Yeah, no, I have no doubt that might be the case.
Well, in that respect, I think we should definitely start looking to Venus and seeing what we can do about that greenhouse effect there. Because if we can tackle that and get the bugs out, man, that will really come in handy around here. Anyway, is there anything else you wanted to throw in here in terms of the anthology or anything?
No, I think I've talked about it a lot. You covered a lot of the questions. Thank you.
Thank you.
And I appreciate you doing what you can to boost the viewership or readership of the anthology, because anthologies are kind of hit and miss from Bain and other science fiction publishers' points of view. But within the field of the science fiction genre, readers expect publishers to put out anthologies. And so it's an interesting conundrum for a publisher because their readership expects them, but they aren't necessarily big money makers, right? So promoting an anthology and the art of the short story which is an art that not many people read or do today, right? I think reading in general is way down. And the art of a good short story is worth preserving and getting out there, because you can explore a lot of really interesting ideas in the short form. And I think anthologies, like the ones I've worked with for Bain, Going Interstellar, Stellaris, and now Ross 248 project, it gives you an opportunity to stretch your mind in many different ways and not just be entertained, but maybe learn something along the way. But that's why I like the short form and the short story mixed with science fact. I think it's my way of reaching to mini me back when I was in middle school and high school and early college, because I read a lot of things like that. So you ask a question and you get me going.
Well, yeah. At the risk of getting you going more, I actually heard from Professor Higgins about the Interstellar Symposium. And
absolutely.
Yeah,
well, let me tell you, these symposia, I'm one of the founders of the Tennessee Valley Interstellar Workshop, which just became the Interstellar Research Group with our annual symposia. And they are a lot of fun. If you've been to a science fiction convention, we try to have these technical conferences where you can get what you get out of a technical conference, good technical presentations in many fields, not just scientific. We have space lawyers, we have philosophers, ethicists, biologists, doctors give presentations about the various aspects that might surround going to the stars and taking the steps to go there, as well as astronomers, SETI experts, people who are concerned about the Fermi paradox. But we always have a public outreach night that involves the community, where we bring in science fiction writers. And at previous meetings, we've had Greg Benford, Larry Niven, Jack McDevitt, Homer Hickam. We've had some really big name science fiction writers. And if you're there, we'd love to have you participate in the panel as a science fiction writer, Matt. And I usually chair that outreach night, and Bain Books publisher Tony Weiskopf usually attends and is part of that. Actually, she usually moderates it. I just usually set it up and participate. So I think it's a great opportunity, and I would encourage you and any of your listeners who have an interest in this topic, don't be scared away from it being a technical meeting. Yeah, there'll be a few papers that you'll sit there and you'll say, I don't get it. But if you go up afterwards and talk to the people who wrote the papers, they'll bring it to the level you do get it. And I would say that probably well over half, if not 2/3 of the papers, the audience it'll be at a level that the audience can understand most of it. And we have a hospitality suite with snacks and drinks as much as the hotel allows. We typically have an art show for space art. We have lots of discussions and working groups. So it's a lot of fun. I had one of the NASA science advisors for NASA's Innovative Advanced Concepts program come to a few of our meetings. And his quote was, Les, this has to be the most fun technical meeting I have ever attended. And coming from like the science advisor to NASA's NIAC program, that was a huge compliment. So anyway, enough of a commercial. Yes, you should come, and so should your listeners. The website is irg.space, www.irg.space, and the group is the Interstellar Research Group. The meeting will be in Montreal next summer of 23.
Yep. And that's the, for those looking online, the 8th Interstellar Symposium. You'll find that easily enough there with the details, more coming as the date approaches. It's July 9th to 13th, I believe.
Yep, that's correct. And if people are interested, we offer short courses in various topics related to interstellar travel, which go 2 to 3 hours. And they are approved for continuing ed credits or professional engineering credits for those engineers that need to get it. Teachers can get their CEUs for that to help meet their minimum requirements for the year in continuing ed. We have little certificates we hand out that are approved by the orgs that allow you to do that kind of thing. So we really try to make this an outreach to as broad a community as we can.
Absolutely. And, well, yes, education and outreach is one of the most important aspects of, and I'd say probably one of the most enjoyable aspects of this whole thing. Well, thank you, Les Johnson, for joining us here and taking us through a wonderful romp through interstellar space, interstellar travel, and the potential for life down the road. And a reminder to all my listeners there, I advise you to check out the links that we'll be following in the episode data for the upcoming anthology, the Ross 248 project, Also for the Traveler's Guide to the Stars and Going Interstellar and other volumes that Mr. Les Johnson here has given us over the years. And also a reminder to check out the IRG 2023 Symposium, which you can learn about by going to irg.space, or just type in 8th Interstellar Symposium into your Google search engine and it will take you there. Promises to be a very interesting time. And so, Mr. Johnson, thank you so much for joining us.
Well, it's great to be here, Matt, and I look forward to meeting you in person.
Absolutely.
Yeah, take care, and thanks for having me.
Yeah, you too. And this has been Stories from Space. I'm Matt Williams. Thank you for listening. Tune in next time.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.